The sine ratio has a symmetry across the y-axis, so we can fold along the y-axis to get symmetry. For cosine, we have something different. So we have been given here cosine theta is equal to negative 0.400. So we've drawn in quadrant 2, so cosine is x, so we draw it left. And then we have this diagram here. And clearly that point defines an angle, which we're going to call theta 1. But there is another position where I can draw the same ratio. Since cos only gives me the x positioning, the y positioning could be down at the bottom or in quadrant 3. So I can draw the same ratio. This ratio is still negative 0.400, but now it's in quadrant 3 and it locates a different position. So this position here, I'm going to call theta 2. So we want to find out the angle positioning. So when I go to my calculator, I'm going to do the arc cos of that angle, of that ratio. So I'm going to do the inverse cosine of the ratio negative 0.400, and that gives me an angle of 1.982. So I'm going to round that to 1.98. And since this position here in decimal form at pi/2 is approximately 1.57, and this is approximately 3.14. We know that 1.98 angle represents the angle in quadrant 2, so 1.98 radians. But there's this other position here. This other position, theta 2, in quadrant 3, how do we locate that? Well, because of the symmetry of the cosine, we can start at 2 pi, and we can go backwards the same amount as theta 1. And that gives us the theta 2, what we call the theta 2 value. Okay, so if I want to find that out, so I'm going to minus theta 1. If I want to find theta 2, what I do is I start at 2 pi, and I go backwards the original angle 1.98. And that's going to give me what I call a theta 2 angle. Okay, so it's a different position. It's not a coterminal. It's a different position that gives us the same cosine value. So it's 4.30 approximately. And so theta 2, going from 0, I'm going to go through quadrant 1, quadrant 2, and I'm going to go past 3.14 to 4.30 as my position. Okay, so there it is. The symmetry for cosine is folding across the x-axis. For tangents, it's different as well, because tangent is not x or y, it is slope. So here I've drawn the tan ratio of 1.75, so I have a rise of 1.75, a run of 1, and I want to then find the angle. So I'm going to do my arctan, okay, or my inverse tan. So the inverse tan will give me the angle. So inverse tan of 1.75 gives me an angle of 1.05. Okay, so that is going to be my theta, and I'm going to call that theta 1. Theta 1 is what I get from my calculator. And what I've drawn here, yeah, that looks pretty much right. Now, the problem with this is that tan ratio of 1.75 can occur in quadrant 1 like this. But if we go around the full circle, that line still has the same slope, okay, but it locates a different position. This position is going to be given by negative 1 left and negative 1.75 down. That's still the same tan ratio, it's still the same slope, but I'm in a different location. And there's a different angle that locates that position, and I'm going to call that theta 2. Now, for any tan ratio though, since tan is slope, really I can just draw a straight line and go to the other side of the circle to get the other angle positioning. So this is how we're going to find theta 2 for tan. We're just going to take the original angle, and then we're just going to go around half a circle to get to the other position that gives me the same tan ratio. So this is a formula that we use for tan. We just go to the other side of the circle. So since sine, cos, and tan have different symmetries, we have different ways to get the other angle, and that other angle we're going to call theta 2. So theta 1 is from your calculator, theta 2 is using symmetry to find the other position. So example 3, we're given the cosine ratio in quadrant form. So I've drawn it here, 5, its cosine is x, so 5 to the right, 8 is the hypotenuse or radius. And we're being asked to find the sine and tan. Okay, so I'm going to find the sine and tan by just calculating the third side. So 8 squared minus 15. So 8 squared is 64, minus 15 is going to be 64 minus 15 is 49. Okay, so 8 squared minus 25. So 8 squared is 64, minus the 25, it's going to give me, that's going to give me 39. So that side length is square root 39. Now we have to be careful because remember, we're always dealing with positioning, and that is going down. So we need to make sure that we indicate that as negative root 39, okay, as our position. Once I've got that though, I now have the side length to be able to state my ratio. Sine theta is equal to negative, because it's down, quadrant 4 is down, root 39 over 8, that's exact value. The tan ratio is going to be the slope, so negative root 39 rise over run, which is 5. And then lastly, we're being asked to solve for theta. So I'm going to solve for theta 1. I'm going to do the arc let's do the arc cos. We're just going to do arc cos. We're going to just apply the arc cos. Okay, so applying the arc cos, I end up with an angle of 0.895. So I'm going to round that to 90. So 0.90 radians. Okay, so that's my theta 1. Now, when I look at the picture though, my theta 1 is not in quadrant 4. It's a positive angle, so it ends up in quadrant 1. So this angle here is my theta 1. Well, I need to use the symmetry because I have the wrong angle. I have the wrong angle right now, and I know the quadrant. I know there's only one angle involved here because it's in quadrant 4, and I have to find that quadrant 4 angle. And that quadrant 4 angle happens to be theta 2. So I can use a formula and calculate theta 2. I can just see that it's symmetrical, so I'm going to go backwards. Instead of going positive 0.9, I'm going to go backwards 0.9. That would be perfectly fine. The same theta 2 can be found using the formula. Now, the answer that I'm going to get is a different angle though. It looks like a different angle, but it's actually not. I get 5.387, so I'm going to round that to 39. So that's going to be 2 pi minus 0.9. Now, this looks like a different angle. However, it is coterminal. Okay, so these are in fact the same angle. Okay, these are negative 0.79 gets me to this point here, or sorry, negative 0.9 gets me to that dot. Positive 5.39 also gets me to the same position. So these are in fact equivalent. These are coterminal angles. So either one is fine. Okay, so the correct answer, although our calculator gave us 0.9, the correct answer for this, the position angle, is either negative 0.9 or positive 5.39 radians.